Okay, let's check this one out here. This is their example. So we've got the sine function here, and that thing's going to the sine of 0, which means it's heading to 0. However, this factor is heading out to infinity. So because the 1 over x is heading to 0, so this is heading to sine of 0. So we got kind of a tug of war going here. Infinity times a 0. What's going to happen? It's not obvious. So will it be a 0? Will it be infinity or something between that? So a way we can get around that is like this. We notice that if we let x be equal to 1, well, let's do it like this. I take that back. I'm going to say let t be equal to 1 over x. Okay, and then we notice that x going to infinity implies that t is heading to 0 by this relationship. So we can write this limit, t is heading to 0, and x is 1 over t, and we have the sine of t. So that's the same as this, sine of t over t, and we're all familiar with that limit. We know that's equal to a 1. So we found that our limit was equal to this one, which is a 1. So that infinity times 0, we sometimes call that an indeterminate form. And, you know, in its limit form, it's indeterminate. You might be saying 0 times anything is 0, isn't it? That's true if it were a direct substitution, and we weren't talking about infinity. Infinity is not a number, so we have to be careful with it. Anyway, so we get 1 for our limit here, and let's see if we can see that on a grapher here. Now I have in here, I have a 1 over x. I'm going to put in, now by the way, here's that form that we showed what happens to the sine of 1 over x as x goes to infinity. You can see it heading downward this way. It's heading down to 0. But anyway, I'm going to put an x in over here. And then let's see what that graph looks like. Whoops. X. I don't know why that keeps coming up, but x. And what this is, times. Whoops. Make that a little bigger. Let's see here. I can just get in there. I'll put in that and then like that. Okay. All right. So there is our graph, and you can't tell exactly, but it does look like it's heading asymptotically. We would have to do a zoom out here to get a little bit better idea. So let's do a zoom out. Just the x. And let's do that again. Okay, so I guess that's a shortcut is F10. We can do that, F10, there it is. Another one, another one, another one. Now, it doesn't, you can see it doesn't take a very large x for this to happen, where it is leveling off at height of 1. If we trace that, is there a trace here? There it is. And let's just put x equal to 30. Oops, lost that. I want to do my trace. So let's see what happens here. I don't know if I can get this to work. Well, maybe we can evaluate it. Let's see what happens here. Let's put x equal to 35. Do I have any equations drawn to evaluate? I thought I did. Okay, well, let's do this. I guess I'm just not. Okay, I scrapped that other graph, or wasn't doing what I wanted to. All right, I have this now. I have TIA3, and you can see pretty clearly, here's my function, x sine of 1 over x. And we are in radian mode. Make sure you're in radian mode. And you can see that it's basically heads to that 1 asymptotically, actually. And you can trace it, and you can see that as x gets larger, it gets to 1 pretty quickly. I mean, it's getting closer and closer. Put in, let's see if we did a trace. Let's try 100. I don't know, it might reject that because it's outside the screen limit. Yeah. Okay, my screen dimensions aren't that big, so I'd have to zoom out on that if I wanted to see that. So let's see, zoom out, enter. I can't even see the graph, but there's a 10. If I make it, let's make it 80. Oops. Let's trace and make it 80. Looks like I'm still not there. Okay. We would think 80 would be big enough, but let's look at our window. Looks like we're only going up to 50. All right, I'll make it a 50 then. Let's do 50. Okay, so now look how close it is. Pretty clear that that limit is going to be